So, hi everyone. What am I going to talk about? I'm going to talk about Lisp. It's a programming language. I'm not going to teach you Lisp because you can find a lot of things about it, but I'm going to try and hopefully hook you on it by explaining two concepts in Lisp, which are macros and condition handling, which they are superior to other languages, at least in my opinion and the opinion of more educated people than I. A bit of just, a bit of history. What is Lisp? Lisp is a language that was created by John McCarthy in 1958. It's basically a mathematical notation for computer programming. It was never intended to be a programming language. And then Steve Russell turned it into an actual language by implementing an interpreter for it. It was actually a challenge between him and John McCarthy back then. And as far as anyone is concerned, Lisp is just a tool. For us computer engineers and computer scientists, programming languages are just a tool. Computers are just a tool. That's not our business. We do math, basically. So it's just a tool, but it's a special tool. And why is it a special tool? Because ever since the beginning, back from 1958, Lisp and its family introduced a lot of things such as garbage collection, closures, object-oriented, a lot of things that are now bread and butter of Java, Python, and other high-level languages. But even till this day, it still have a few tricks up its sleeves, like macros and conditional restarts, which I'm going to be talking about. Okay, so I'm just going to give you basics so you can follow with me in the code, nothing else. If you want to learn the syntax, that's a bit, for you. Functions are represented as a list. So if you want to write 4 plus 2, you write plus 4, 2. And it's a prefix notation. So the first one is the one that you're going to solve on. So divide 12, 6 gives a result of 2. It has built-in data structures, and lists are key for Lisp. All S expression, anything in a list is called an S expression. They must return a value, all of them. They might return multiple values. So if you want to return 2 numbers, you don't have to return an array. You can actually have a function returning multiple values. And in functions, arguments are always evaluated left to right. So if an argument is a function, it's evaluated. And then another argument is evaluated. And then eventually, the function is evaluated. And this happens in almost all languages, right? If you take any function right now and you pass to it an argument, another function, that function is actually evaluated before the argument is a value. So just a quick example. For example, if I want to write the square function, I would write it as defun square of x is the multiplication of x by x. That's your basics, no more basics. Now for the interesting concepts, I'm going to talk macros, conditions and restarts, and maybe some other time, if you'd like, about the advanced object-oriented system called sloth. Let me start with conditions and restarts. Now, in an error handling system, you have basically, you can signal a condition, which is saying we have an error. We have condition handlers, which is binding a recovery method to that error specifically, and we have restarts which define the recovery method. Now in advanced languages, you have try-catch, right? Try-catch, you throw an error, for example, that's the signaling, and your catch is your condition handler and restart together, because in the catch, you're saying how you recover. Now in most languages, you think, this makes sense. In reality, you can make this a lot better, but most of the time, you don't realize that, and this is why I'm telling you this text. So let's take, for example, parse text. Now, parse text is supposed to be a function that will simply tell us if the length of this text is less than 5, we'll print it, but if it's bigger than 5, there's an error. Parse text itself should not have a try-catch. It just raises an error if things are, greater than 5. So it's raising this error that we're called malformed text error. Nothing more, nothing less. Now we have this function called parse text list, which given a list of text, it's going to parse every text element, and if there's an error, it's going to say if it's we're going to define 2 restarts. If it's a critical text entry, we're going to print big error. And if it's a normal text entry, we're going to print nil. So far, it's looking very weird. How do we use this? OK, so let me explain it. In a typical try-catch, the ones that you know, you would say simply, I would say handler case. This is your try. This is the body of your try. And your catch is, if it's malformed text error, print, oops, an error happened. OK? I'm going to define parse normal text. I'm going to say, if I bind to the type error, malformed text error, which I've defined, if I'm going to bind that any time a malformed text error happens, I'm going to invoke the restart normal text entry. And if you remember, normal text entry simply prints nil. And for critical data, I'm going to say I'm going to invoke the critical text entry. So what happens if we run this? This means that if I try to write hi leb geeks by, this is the text, and I'm running through parse normal text. Leb geeks, because it is normal, bigger than 5, it's going to be hi nil by. OK? But if I go through critical text, it's going to be hi big error by. Notice what happened. There is the function itself, parse text, knows nothing about how to handle that error. The function parse text lists does not decide what is going to happen. It has no decision about the strategy that I'm going to follow in this particular text. But the higher order function, the one that's saying, oh, wait, this is a critical system log that I need to send an email to the administrator, can now decide if an error falls, I send an email. But if I'm parsing, let's say, a web log, not a big deal. I'll just throw it in another file. This strategy is decided by the application. It is told to the actual function without the need to having to write multiple functions or having to write multiple try-catch or even define new errors or new conditions. And more importantly, if I run the typical try-catch, notice what happens. What happens is all the function has died. In the try-catch, even though I'm trying to do the same thing, I'm still calling parse text list, just like I did it here. Okay? I still have killed all the results of parse text list. I cannot maintain the context of that particular function. What happens in your normal try-catch is that the stack is rewind. You lose that function. You simply go out of it. But in Lisp, you don't lose that function. You drop to the debugger in that function. You can choose to say, I want to restart for that particular case. And this is, this is something called conditional signaling for handling errors, and not a lot of languages have it. Basically, Lisp family. OK, so that's for condition handling. Let me tell you a bit about Lisp macros. Now, Lisp macros is another thing. It allows you to programmatically generate code. It allows you to extend the language as you see fit. It runs at compile time. This is very critical. And with its power comes responsibility. Let me explain it in a very simple way. Let's say we're going to define a macro. And this macro is very simple. We're going to say less than 0.5. This is the macro. And we're going to have a probability, an else, and a then. And we're going to say, if it's greater than 0.5, then, and then else. Now, in Lisp, this quotation, the commas means evaluate then, evaluate else, evaluate probability. You use it in this quotation. I'm not going to go into the syntax. But the idea is, this is the function. Just remember it for a second. All of you are going to say, OK, wait, why don't we do it a function? Why do you want to make it a macro? And right, we can do this fun as a function, less than. Now, what's the difference between this and that? Let me show you an example. This is the first one. I'm just going to read it out in normal language. I'm going to define a variable x that is equal to value 2. And I'm going to say, print the macro less than 0.5 with the following arguments. 0.1 and the function set fx to 3. So x's value is 3. And print the value right. And the other else, so this is the then. And the else is set x to 4 and print high and then return left. If I run this, what do I get as an output? I get right and 3. Why do I get this? Because 0.1 is less than 0.5, so only this value has been evaluated. But you say, wait, didn't you say that all languages, we start by evaluating the arguments left to right? Yes, you do, but this is the power of macros. Because it's at compile time, you are not required to evaluate anything. You're writing the functions that will take place. So arguments are not evaluated. It is only going to be evaluated if you go into it. So if I go into the else, then it's going to be evaluated. If I don't go into it, it's not going to be evaluated. The difference is if I run the same code for a function less than 0.5f, what's going to happen is x is going to have value 4, because first one is going to be evaluated, returns right, second one is going to be evaluated, returns left, and then the if function is going to call. What happened here is that the evaluation took place. Macros allow you to work before things are evaluated. Now, some of you might not have realized how dangerous that is. So I'm just going to give you an example. Let's say we defined square. Square 2, just for you, because I did all this code in the same package. So anyways, square 2 is defined as x times x. Now, we said let x equals 3 again, and we said we're going to call the function square 2 increment x. So this is just like x plus 1. What's the value of this? If you think the value of this is 16, you're wrong. The value of this is 20, because it's a macro. Remember what we said? It's not going to evaluate. It's changing code at compile time. If Lisp gives you a lot of tools to debug, one of them is macro expand. If I do a macro expand of what if calling this actually results in, it's going to show me that in reality, this macro is going to be expanded into the multiplication of increment f x, and again increment x another time. So it's really, when calling it, it's multiplication of 4 times 5 and not 4 times 4. And this kind of power where you can actually change a function, change its arguments, even possibly define new functions. For example, when I'm writing web applications, I don't have to write every time checks on did my SQL database fail, or I need to write some checking on authentication, because I define a new function for my macros in a macro and say this function will always introduce a bit of code before actually deciding what's the body that's going to happen. And this kind of power you don't have in other languages. So Lisp has tons of tutorials and books online. Paul Graham has written a few books on it. It's a standard. There's the hyperspec for it, and there's a book called Giga Monkeys, which is beautiful. For all of you that are still in university or just going out, there's a book called Structure and Interpretation of Computer Programming. If you haven't read it, please do. It's probably the most important book you will ever read. And it's based on Scheme, but it's still a Lisp family, Lisp 1, but anyways. If you have any questions about this or anything else, I'm happy to help. And if you would like to start working in Lisp, download Emacs. If you don't know Emacs or Vi, you really should learn one of those. It's a tool. You can download Slime as well, and you have a working Lisp environment. Thank you.